Yeah, once again, good morning all. Uh, yeah, in continuation of last lab, I think we completed first experiment that is single linked list, second is double linked list, third is subtle linked list. Here, I think most of the students are executed. Some of the students are already uh, executed and they are updated the recorded observation. Even they forwarded to my official mail. Still, any students are not executed, please try to execute and update your observation and record. And the same thing you must forward to my official mail. Already I shared my official mail. So based on that, I can understand the people who are done that particular experiment and that things are I am going to share in my drive. So once you come to the laboratory examination, then based on that I can assign the marks for individual students. So that is only the possibility. That is why I am asking continuously. Please try to execute. Still, in first three experiments, you people, anyone is having any doubt regarding single, double, and circular. If you no doubt, then I will go with the fourth experiment. Even we know that already we discussed in the class also, but even still, please respond quickly. Based on that, we'll go with the next experiment. Hello, is it audible? Is this my voice is audible? Hello.
Audible, sir.
Yes, sir.
Yeah. Shall we go with the fourth experiment? No one is responding means. Hello.
Yes, sir.
Yeah. Uh, Before starting, once we'll check the syllabus. Just I'm going to share your syllabus. The fourth experiment is the implementation of stack with help of using array and linked list. Pointer is nothing but in your syllabus they mentioned pointer. Okay, this is the fourth experiment of your data structure laboratory. Write a program that implement stack operations using arrays and pointers. Pointer is nothing but a linked list. Don't confuse. Is it okay? Is it clear? Yeah. Now, anyone before starting the experiment, please tell me anyone what is a stack and what are the properties of stack. There are two experiments are there in this fourth experiment. Okay, using array, using linked list. So before that, we must know exactly what is a stack and what are the properties of stack. Hello, I'm asking. I'm asking properties of stack. If you don't know, then again I have to explain what is stack and operations. Already we discussed. Already it is there in your first mid examination. The people are almost attempted. Quickly, anyone. What happened? Second year A section. The people are more responsive today. What happened? Without response, I can't continue. Hello, is it audible? Whatever I am asking, is it audible?
Yes, sir.
Yeah, then respond. Anyone. Otherwise, I will stop the session. What is the use? if you are not responding. Fast. Means no one is don't know about stack, right? Hello?
Hello.
Yeah, tell me.
A stack is a linear data structure, and we will
Mm,
perform push and pop operation using one end, which is known
mm,
as top, and the other end is closed.
okay. Why you people are taking this much time? Any other good pre-answer? Any other?
It follows the last in first out or first in last out principle.
Yeah. Yes. Right. Your response is required. Already I told you many times. If you are not responding, then it is I cannot continue because I want to know really how many people are really following or not. Okay. Now stack is a linear data structure. Here it is having only one end. Here through that end only we are going to insert and delete the elements. Here, when we are going to insert any stack, it is called as push operation. When you want to delete an element from the stack, it is called as pop operation. Push and pop. So both are going to perform only. Is this screen is visible?
Visible, sir.
Yes, sir.
Yeah. Here, if you observe, here one end is closed, another is open. So this end is called as top. Here pushing of the element and popping of the element means insertion and deletion. It takes only one end which is called as top. So always we are going to follow this order. That's why it is going to follow first in, first out order or last in, last out order. So this is the stack. Here can anyone tell what are the two errors are possible in stack? Hello? What are the possible errors in the stack?
Overflow and underflow, sir.
Yeah, overflow, underflow. What is the meaning of overflow?
When stack becomes full and we try to insert another element.
Yeah. When the stack is full, even though we are trying to push element, then that situation is called as overflow because that element is not inserting or pushing into the stack. Then that situation is called as overflow. Then what is the underflow?
When the stack is empty, even though we try to
When the
pop
stack
elements,
Yeah. When the stack is empty, even though we are trying to pop the element from the stack, that error is called as underflow. So these are the two important errors we need to use to implement the stack. Correct. Based on all these properties. Is it right?
yes, sir.
Yeah. Now the implementation of the stack using array implementation. Now tell me before discussing of implementation of stack using array. So first of all, we want to know array nature. So what is the nature of array?
Static nature.
Yeah. The array is having static nature. Means what is the meaning of static nature? What is the meaning of? Yeah, tell me.
We cannot change. We cannot change the. I mean, it is fixed size. If we give a size that is fixed, we cannot change it further to decrease it or to increase.
Okay. Who is this? May I know your name?
Yogita Sri.
Yogita. Okay. Still, some more information is required. Anyone? Stack is having, array is having static nature. Means, so when you wanted to use array in any implementation, you need to specify the size of the array. Before using that array, you need to specify the size of the array. Means you have to fix the size of the array. So once we are fixed, then there is no chance. Yes, there is no. First, this point you have to mention Yogita. Everyone. And then you can use that array wherever you want. So, yeah, in that case, your definition is right. We cannot increase, we cannot decrease the size of the array. So that this array is having static nature. Once you are going to implement stack using this array mechanism, the problem is we cannot increase the size of the array and we cannot decrease means you need to specify the array size. And that's why that stack also called as, tell me, that is why the stack also called as
Static stack.
static stack. Very good. Now I wanted to use this array for implementation of the stack. I need to define array size here. For example, the type is if I take STK, if I take the size is for example global declaration, n here I am taking, if n equal to 4 means the stack size is 4 only, correct? Yes or no? Yes or no?
Yes, sir. Yes, sir.
Yeah, data structure is prepared already. Data structure is prepared. Means we are going to specify the size. Now coming to the program, you know this menu bar, 1 for push, 2 for pop, 3 for display, 4 for exit, you know very well. These are the functions. Now, once you wanted to use that stack, you need to define the structure. Yes, I define the structure. Your stack max. So I have taken max of 10 here in this program. Means it is going to accept the stack going to accept only max of 10 elements. Here, okay? Clear?
Yes, sir.
Yes, sir.
Here I am taking for showing as example n equal 4 I am going to take. Right. Now structure is ready. Now this stack size is only 4. So this is 0 indexing, 1 indexing, 2 indexing, 3 indexing. Here, arrays are having indexing, but in this stack we never use this indexing mechanism. You know very well why. Already I told you. Now here, initially the top is pointing to what? Initially the top is pointing to what?
-1.
-1. Why -1? Already I told you many times, right? Now we need to implement the operation. The first operation is push. The push of X. One element I want to push into the stack. Now tell me when I want to push an element into the stack, then what are the conditions we have to verify? First, what should we do?
Whether the stack is full or empty.
Yes,
Stack is full or not.
whether the stack is full or not. If it is full, then the first condition we need to check the
If it
stack
is
is.
full, we can't.
We can't.
We can't push it if it is full.
If it is full means, for example, your top is here. Hence, elements are like that. Now I am trying to push x value is 20 I have given. Now, is it possible to push this 20 into the stack?
No, sir.
No.
No, sir.
Why? Why stack is full? Because array is having static nature. So that's why we cannot push. Stack is overflow. Clear? Clear.
Yes, sir.
For that, what is the logic? What condition we need to check? How to know the stack is full? If top,
Top
tell
is
me.
equals to max minus 1.
Yes, very good. Top equal to max minus 1. When top equal max minus 1, we cannot push the element here. This is the code. You know very well already. So if top equal to max minus 1, then we cannot insert element into the stack because stack is overflow. Yes or no?
Yes,
Yes,
sir.
sir.
Sure. Yeah. Here, other than this, we can insert element in any case. For example, if the stack is not max minus 1, maybe the top equal here, maybe the top equal here, maybe the top equal here. For example, we are inserted already some elements. Maybe stack is like this. In this case, top is here. Even though we can insert, even if it is there, also we can insert because we have the position or location. Yes or no? That's why, except top is max minus 1, remaining all the cases, we can insert element. Is it right? Is it right? Is there any other constraint? Hello? Hello? Is it audible?
It's right, sir.
Yes, sir.
Yeah. So remaining all the cases we can insert because some positions are there. So that's why directly we can write else without any other condition. Directly we can write else. Here enter the element. Here element we are going to read and stack of plus plus top equal pre-increment already we know stack of plus plus top equal. You are assigning that particular element into particular location. So means, for example, my top is here. Now I want to insert X. Where we want to insert? In this position. That's why pre-increment plus plus top star stk, you know, equal to X. Means this element we are going to read from the end user and we are trying to insert this area. If you want to insert this element into this area, you need to increment your indexing. That's why stk of plus plus top equal to X. Now that element is going to insert into appropriate location. Anytime you want to insert, you need to check that stack is having space or not with help of if top equal to minus 1. Other than this, you can insert with help of pre-incrementing of your tab. Then you assign whatever the value you want to insert. Understand? Hello? Some noise is coming. Please unmute. Yeah. Is it fine? Hello?
Yes, sir, it's clear.
Yeah. Now coming to the part. Now, when I wanted to perform pop operation, we need to specify anything because always which element is going to delete from the stack when you want to perform
The top element.
top element. That's why we no need to read anything directly. The top of the element is going to delete from the stack. Now
Sir,
tell me, yeah,
Keshav is waiting outside, sir. Last 10 minutes. I accept him.
here it is auto admit already. Who is that guy is waiting?
Keshav, sir.
I think he already joined.
Just now I have came.
Yes, that is what I am telling. Okay, in time you come. Keshav, please join. Whatever the time I am specifying, even I am giving 3 to 4
Since
minutes.
I'm waiting 10 minutes, sir. Network
Yes,
issues.
yeah. The classes started 10:45. Still, even I given 4 to 5 minutes time to start. Please understand everyone. Please try to join because of you, remaining people are going to lose the things. Understand your things, please. Okay, okay. One or two cases is there. Not regular. Any other time, okay. Sometimes it will be happen. I to accept, but don't do this problem regularly. Okay, please. Yeah. Okay. Right. Come to the point. And now pop. Now, what are the when we cannot pop the element? When we cannot pop the element?
If top is equals to -1, then we cannot pop the element.
Yeah, very good. Means the stack is empty, we cannot pop. If the stack is empty, even though you are popping, what is the error it is?
Underflow.
Underflow error, very good. Here underflow error will come. Means no element is there stacked, you are trying to pop the element. Here the condition already girl is saying, who is this? May I know your name? Hello? Yeah, top equal to -1, even though we are trying to pop the element. Now stack is underflow. Here same logic. Okay, if top equal to -1, then we cannot pop the element, it is underflow. Here remaining all the cases, we can pop the element. Yes or no? Means maybe the top is here, or maybe the top is here, maybe here, maybe here. Remaining all the cases, except top is pointing to -1, remaining all the cases, we can pop the element. Yes or no? Hello? Is it audible?
It's audible.
Yeah, please respond. Okay, then only I can continue, then only I can understand. Really you are following or not, please. Right. Now remaining all the cases, except top equal -1, remaining all the cases we can pop the element. Correct? Hello? No response. Is it right?
Yes, sir.
Yeah. Now, how to now else we need to write the pop logic. How to write the pop logic? Your simple logic is what? Top must be decremented by 1. That is what exactly in array. We cannot delete the element. Simple, you can write top equal to top -1. Clear? Because it is a static one. Because we are using array here. Yes or no?
Yes, sir.
Yeah. You respond. What happened? Huh? Next one is the display operation. You know, the display is nothing but we are going to display the first element to last element. Means from top to until the top move to the -1. If you don't move the top, just you have to define one temporary variable equal to top using this element temporary variable you need to move until t equal to -1. So this is what exactly. While t is not equal to -1, then we need to print uh, stk of t. Like that, we need to print all the elements until t moves to -1. Is it clear? Is it clear?
Yes, sir.
Yeah, like this. In time, if top equal to -1, yes, you know this condition compulsory. Okay, you know top equal -1, you cannot delete it. You cannot display any element because stack is underflow. So otherwise, we can print the element. Here I have taken I equal top here. Then we can print up to I moves to -1. Clear this? Stack implementation using array. Even you can use for loop also here, and while loop also. Whatever the way, whatever the conveniency you people are having, you can use it. Is it clear? Program is clear.
Yes, sir.
Clear? Yeah. Just I'm going to run this program. Please check. Yeah. Now this is the menu bar. Already told you. This is the menu bar. One for push, two for pop, three for display, four for exit. You know how to write which cases already. Now enter your choice. Now I want to display the element. Then three. The stack is empty. Yes, stack is empty. Because top is pointing to -1 initially, you know. Even I wanted to apply pop. Even it is going to show stack is empty. Right? It is working. Now I'm going with 1. Now enter the element. Here push means enter the element. Here I entered. Now if I wanted to know what are the elements are there, 3. Yes, 23 is there. Again I want to push. Again I am going to display. Yes, 43. Here it is inserted top of the 23. Again I am going to insert one more element to display. Yes, 55 is top, right? It is inserting, right? Always from one end only, right? Hello? Hello? Is it audible?
Yes.
Now it is inserting as per the first in, last out or last in, first out, right? Hello?
Yes, sir.
Yeah. Now I will go with the pop operation. You know very well. When I am going to pop, which element is going to delete? Now tell me. Out of this example, which element is going to delete?
55.
Yeah, 55. Because 55 is the top element. Just check it. Okay, 55 is deleted. Then I want to display the 55 is deleted or not. Yes, deleted. Clear? Here I want to apply pop. Deleted. Again I want to apply pop. Deleted. Again I want to apply pop. Stack is empty. Understand everyone this program, how it is working? Very simple. Clear?
Yes, sir.
Okay. Shall we go for implementation of stack using linked list? Hello?
So,
Shall we go for linked list? Using linked list?
yes, sir.
Yeah. Now coming to the implementation of stack using linked list. Now tell me, what are the advantages of there here comparatively arrays? Response is required.
Sir, there will be no overflowing issue because linked list is dynamic memory allocation.
Yes, very good. Linked list is having dynamic nature because so whenever you wanted to insert element, you need to create the memory dynamically so that so whenever you wanted to insert element, then dynamically we are creating the memory so that it is having dynamic nature. That's why this linked list is having this array is this stack is having dynamic nature. That's why it is a dynamic stack. Clear? Clear? Hello? Hello? Clear?
Yes, sir.
Yeah. Now coming to stack representation, with help of linked list. Here we no need to define the size of the uh, stack here because it is having dynamic nature. So that's why we have to use here single linked list. Here, what is the node structure? What is the node structure?
Data and
Huh?
there'll be two parts, data and address. One is for data and one is for address.
Yeah. One part is for data. Node is divided into two parts. One part is for storing the data. Another part is storing for address of next following node, which we are going to connect. So like this, our nodes are divided. Node is divided into two parts. Here for this node structure, we need to prepare. You know how to prepare single linked list same way. Structure node, no means structure name is node I am taking. Then based on that, okay, integer data if I take, then I can take int data. If you want to change, then you can use char also if for character data storing in the stack. And the next is a pointer, which is a type of structure node. Like that, we have to define. Yes or no? Yes or no? Hello?
Yes, sir.
This is the way. Here now, initially, the top is what? Here, initially the top is pointing to what? In this dynamic nature, initially top is pointing to what?
Null.
Null. Yeah, very good. Here it is a dynamic representation. So null, not -1. Yeah. Now this is the way we are defined the structure of the linked list for implementation of stack. Okay. Now structure is there. Now same way we have two operations here also. One is push operation. Here whenever you wanted to push element, we need to call this particular node, that is a new node, and create the dynamic memory allocation. Later read the NN data from the user and assign the NN next equal to null. Correct? Yes or no? Hello?
Sir.
Yeah. Now, for this push operation, if you observe, right. Now here, so when I wanted to use this, whenever I want to push, yes, here I have to create, means I have to allot the memory. I have to allot the memory. After allocation of the memory, I'm going to give the next equal to none. Then I'm going to add the data for the particular element. Are you clear? Yes or no? Yes or no? Hello? Allocate the memory, then assign the next is null and add the data part for element, whatever I'm going to read from the user. Then I'm reading the data here. Clear?
Yes, sir.
So this is the reading of the data. Clear now?
Yes, sir.
Hello? Yeah. Right. Here now when I want to insert now that node is new node is ready now. Now I want to push this new node into the stack. In same way, here what are the conditions we need to check if I wanted to push? Generally, not for linked list mechanism, generally. Can anyone tell? Hello? When you wanted to push, what is the condition we need to check?
whether it is empty or
No, no, no. Don't tell the dynamic way. Normal way you tell. When you want to push, what you need to check? Respond quickly. The stack is full or not? Yes or no? Means overflow. General. Correct? Hello?
Yes, sir.
yes, sir.
Yes, sir.
Responses are required more quickly. Otherwise, I told you many times. Otherwise, I cannot contain. Yes. Sure, but the linked list is having dynamic nature. That's why we can insert n number of elements. That is why there is no chance of overflow error. Stack implementation is the linked list. Correct? Is it right? Hello?
Yes, sir.
Today, what happened? Yeah. Yeah. So that's why here that condition is not applicable for this stack implementation using linked list. Then which condition we need to check here? Which condition we need to check? Just now someone is given. Hello.
Whether the stack is empty or not.
The stack is empty or not. Here, how to know the stack is empty or not? What is the condition?
Top equal
If
to
top
null.
is equals to null,
If top equal to null, then if the top equal to null means empty. If it is empty, what should we do? If the top is null, then tell me what is the logic? Respond here.
increment the top.
Increment the top.
Top equal to n.
Top equal to n. Now your new node is become as a top. Correct?
Yes, sir.
So this is one. This is your data. Whatever the data it is having. Correct. Here, if top equal to equal null, your top data is element. Here your element is inserted. So this is what exactly. Understand?
Yes,
Understand?
sir.
Yeah. Now else means stack is not empty. If the stack is not empty means the stack is having some elements. So then you need to connect it. Means your NN you need to connect. Here your NN is like this. This is null. This is maybe the Y. Now tell me, if the stack is not empty, you need to insert this NN. So now to write?
Increment the top and top next to
Increment.
this n.
Who is this? May I know? Who is this? May I know your name? Hello? What should we do? I think Gayatri, correct?
No, sir, it's Yogita.
Yogita. Now tell me the answer, Gayatri. You tell me. What should we do now? Hello?
And then next is equals to top.
There is no chance of incrementation. It is a dynamic, not for static, not for array. Correct? Hello? No boys are responding today. Why? I don't know.
If you understood.
Now this is a top and this is NN. Now don't tell increment. There is no indexing. We are dynamic, right? Now you know the top, you know NN. Then tell me how to write NN next equal to top. Correct? Yes or no? This is your NN. Correct? Then what is the top now?
And then
Respond
will be
time is.
NN will be the top.
What is the logic? Top equal to NN. Correct?
Yes, sir.
Yeah. Here, this is the way we can push the element. Here, this is the way. Here, top next equal to top data equal to element, top equal to M. So this is the way you can push the element. Now coming to the pop operation. So now tell me the pop. So when we cannot pop the element,
When
If
it
the
is
stack is
underflow.
empty.
when the stack is overflow, underflow, overflow. The stack is
Underflow.
overflow or underflow. When the stack is empty, here this condition will work in both the cases. Because if it is empty, we cannot delete. When the stack is underflow, we cannot delete the element. Correct. Then what is the condition?
If top is equals to null, then it is empty.
Yeah. Top equal to null. Then it is empty. So we cannot delete the element. Else, remaining all the cases, if the stack is not empty, the remaining all the cases we can delete it. But again, we need to check two conditions. The stack is not empty. Correct? Is it right? Because stack is having one element or more than one element. Because if the stack is having only one element, then it is looking like this. After deletion of this element, one element of applying of pop, then top is pointing to what? If stack is having only one element, after deleting of this element, the top is moves to hello.
Top next.
Here, only one element is there, yeah. What is the top text here? Hello? People are not responding. Generally, what is this? Two situations.
Null, sir.
Null. Yeah, okay, you can use same logic for here also. If you use, it moves to null pointer. But in the same case, your stack is having more than one element. After deleting of this top of the element, top moves to top next. But it is not a null, it is a data. But it is a null. But it will work for same logic for both the cases. Understand? Understand the situations, clarification. Hello? Today, what happened here? You people are not
Yes, sir.
responding. Yeah. Respond. More response is required. Right. Now, for that, you are how to top, then use one temporary variable and assign to top, and top moves to stop next. Top will come here. Then this is a t. Now free of t. Clear? So like this. Top one equal top. Here I have taken top one. The top equal top next. The element is move popped. Then top one next equal to null. Free of top one. Okay. Here I have taken instead of t, I have taken here top one. Clear this?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Now coming to the display. Here the display operation is same. The display operation is same like how we are used in the other implementation is also same. So you first of all you need to check the stack is empty or not. If the stack is empty, we cannot display any element. If the stack is not empty, then you can take one temporary variable, the temporary variable assigned with the top. Then you have to into the t data, then move to t next. Then from the t data move to t next until t moves to the null. Once it is moved to the null, then that will be out of the loop. So that is why simple. Already we know if top equal to null, now stack is empty. Otherwise, okay, you have to move top until top one is not equal to null. We have to print the top one data and top one equal top text. Like that, we need to move unless we found the null. Once it is moved to null, while we found, then it will be displayed. Clear? The display function is clear? Yeah. Now just I'm going to the element 45 where it is inserted with the help of a display method. Yes, it is 45 inserted on top. Yes or no?
So your
Yes or
screen is
no?
not visible.
My screen is not visible. Oh, sorry for the inconvenience. Why it is automatically it is gone out? I don't know. Now is it visible now?
Yes, sir, it's visible.
Yeah.
Yes, sir.
Yeah. Now again I am trying to insert one more element. Now 67 inserted. Then I will check. Yeah, it is inserting on top of the stack only. Correct? Yes or no? Yes or no?
Yes, sir.
Yeah. Now I want to delete the element. Here, then I am using 2. Then which element is going to delete out of this 67, 45, 23?
Yeah.
67. Why? It is a top of the stack. We'll check it is doing or not. Yes, it is deleting. Yeah, 67 only. Right. It is doing that. Now it is working. Correct? Even I will apply again pop. Yeah. Top value is 45. Yes. Now again display. Just 20. Again I am popping. Again display. Now stack is working. Now it is showing all the possibilities. Is it clear, everyone? Implementation of stack using linked list and implementation of stack using arrays. Hello?
Yes, sir.
Yeah. Yeah. Please, everyone, please try to execute these programs. After execution, you write in the observation and record those things you share to my official mail. Then I will update the things. Okay, don't waste your time. Don't wait end of the semester. You complete whatever the experiment we are doing on or before next laboratory. So that's why parallelly you people are going to finish theory as well as laboratory also. You know, the January 30th is the last date for your instructions. 31st is the last day. 31st is again Sunday, right? That's why 30 is the last instruction day. That's why please complete as early as possible. Whatever the things are there, and attend classworks regularly and maintain the attendance percentage above 75. Otherwise, you people are going to be retained. Please contact your class teacher for further clarification of your attendance and check that attendance and manage your attendance. Okay. Okay. Is it fine, everyone? Now up to